Hello, so today we are doing this problem called binary tree zigzag level order traversal. And so the problem says we have a binary tree and we want to return the zigzag level order traversal of its nodes. And that basically means that we get a level from left to right and the next one from right to left, and we keep alternating this way. And so for example here the first level is 3, the first level is left to right, so the value is 3. Second level is right to left, so that's 20 and 9. The level after that is left to right, so it's 15 and 7, and we keep going like this until we traverse the entire tree. And so how can this problem be solved? So this is like a tree traversal problem, and so we know we can definitely solve it with BFS, since BFS goes level by level, and so we could just keep some track with some Boolean value to know when to go left to right and when to go right to left. But we can also solve it with DFS, since with DFS we can at here have the level be 0, but when we go to the children, pass level to be +1. And then for each level we can basically, so solving it with DFS would be something like this. So with DFS, basically pass level to each call, to each DFS call, and if level is even, then we can, so if level is even, then add the value to the end, right, because that's left to right. And because if you look here, 0 is the first level is even, and then the second level, which is 15.7, it's even also, and it's left to right. 1 is odd, and it's right to left. And we will, if we had a long tree, we will see that it starts out as even, and then switches with, starts out as even, which is left to right, switches to odd, which is right to left, and keeps going that way. So if the level is even, we add the value to the end of the level list that we are going to keep track of in, like, we need a result here, array that is indexed by level. And so basically here that means that if level is even, we can just do res level dot append the node value, right? But if level is odd, then in that case we need to add to the beginning, because we want right to left. So we are traversing with the DFS like this, 9, and so if the level is odd, which means we need to do right to left, then that means we need to have, and say we already had 20, we need to insert 9 so we already had 9, and we are now traversing, because we are going this way with DFS, we add left first, and then when we encounter 20, we shouldn't add it to the end, because this is a right to left traversal, and so we need to add it to the front. And so basically if level is, then add the value to the front of the level list. And that would mean just something like level dot insert at position 0 to add it to the front. We add node val. We could also essentially use a queue, right? And then here just do append to the right, which is just append. But here do append left, which would be appending to the front of the list. That also works, and it's even better because it's this insert may be a little bit worse because it's O1, because it needs to traverse to put the value at the front and push the rest of the values back, like to advance the rest of the values so that it can put the value at the front, right? Okay, so let's implement this then. So we know we need DFS, and so we have a res, and then we need DFS, start DFS on the root. We need to pass the result so that we can append to it, and we need to pass the current level, which starts out as 0. And so we need to define our DFS that gets a node, gets res, and gets the level. And at the end we can just return that res. We will be adding to that list. And so here, if the node is empty, then we can just return our res. No need to proceed further. And then we need to check if we already added the value to the current level, because if we didn't, we need to create the new list, right? And so we need to check if length of res, so basically this checks, is this the first element the first node of level. That's pretty much it. If it is, then we need to append an empty list to res, so that if we do, this is basically so that if we do res level, we can get a value and not get an index out of bounds or something, okay? And so now we added that list, and now we can just proceed checking if level is even or odd. So level modulo 2 equal to 0, so this is level even, sorry. And else, this is basically level odd. So this here means left to right, and this means right to left. And in this case, what do we need to do? We need to say res level. We said we need to append, so we need to just append to the rest of the list, to the end of the list. And otherwise, we need to add to the front, which means we need to insert a 0, no val, and we need to now we added the value, but we need to explore the left and the right of, we need to continue the DFS on the left and right. That's basically the template of DFS, and so that means we need to do DFS on node.left res, and the level for the children is the previous level plus 1, for the level of their parents plus 1, and we do the same thing for right, and that's pretty much it. So it's passing for this case, for this tree. Let's just complicate this tree a little bit more. We'll say 11, 3, 80, 80, let's say we have 23 here, and let's run this. Okay, so that also passes. Now let's just try with the null empty tree. Okay, so yeah, Leetcode can't parse it, but our result is valid, so that's cool. Let's submit and see. Oops. How can I get rid of the tree visualizer? Okay, cool. So now this solution passes. So we are just using normal DFS. The only thing we are changing is we have this auxiliary data structure to keep track of the result that we want to return, and we are flipping the, depending on the order, we are inserting differently. And usually this is the template of DFS. We go left and right, and here we process to get the result that we are looking for. So that was for the first solution. We can also solve this with BFS. So let's think about that. So BFS solution, we do the same thing that you usually do for BFS, except we need to do the same thing for left to right. And so, but with BFS, since we know that at one time we are traversing one level, so we can just determine if current level traversed by BFS is left to right or right to left. And depending on that, so depending on if left to right, I'm just gonna, so this means left to right, so let me just say this is left to right and this is right to left. So if left to right, that means that the first element of the level should be inserted at position 1, at position 0. Then the second element should be inserted at position 1, just the normal stuff because it's left to right. And you get the idea. It's 0, 1, 2. These are the positions, right? So basically that means that for left to right, the positions are just are 0, 1 until the size of the level, right? Because in BFS, in the queue, we already have the entire level, right? But what happens for right to left? Now for right to left, actually, it's a little bit different, since the first element of the level should be at the end because it's right to left. Because here you can see 9, 20, the first element, which is 9, should be the last one, and the 2 should be here. So the first element should be at position length of level minus 1, right? Because it should be the last one. And the second one should be at length of level minus 2, and you get the idea. Length, third element of the level should be minus 3. And so the positions would be length of level minus I, because so I for the first element is 0, and then we did minus 1, so minus I minus 1. And then for the second level, for the second position, that's minus 1, so that it gets to be minus 2, right? So minus 2 here, minus 1, sorry, minus I, and since I is 1, that makes this minus 2. And the last one would be 0, because basically it's reversed. And so the indexing of where we put the element that we are traversing in the level is different, but the rest is just normal BFS. So let's do this then. So same thing, we need the res, and we need the queue for our DFS. And in Python, we are going to use collection is.dequeue, and we need to start out with the root in the collection. And we need to determine if the current level is left to right or right to left. And of course, for the first level, we start out as left to right, and so that starts out as true. And now we need to traverse the queue. You can notice here that I'm not checking if root is null, just to avoid an extra if check, because if I do any queue here, if the queue contains only a none value, which would be the case if root was none, then this condition wouldn't be true, it would be false. If I demonstrate this with just none, so this is the case when root is none, then we get false. But if root wasn't empty, so let's just say it's 1, then we get true, and we will enter the while loop. And so this basically makes it allows me to avoid the initial if check. And so we have the size of the level, or let's call it a length of level. That would be q dot the length of the queue. And what do I need? I need the current level. So the current level is, let's say it starts out as, and then I'm going to replace the values with these indexes, but just for initialization, it's this. And then what I'm going to do is I'm going to go through the length of the current level that I'm going to traverse. And what we are going to do is we are going to check if, we are going to first pop the node that we are going to add, and so that would be pop left to pop the first element, and then we are going to check if we are left to right or right to left. And so actually we are just going to determine the index based on whether we are, so this is right to left, left to right, or right to left. So if it's left to right, the indexing is this. If it's right to left, the indexing is this. So our index is going to be I if we are left to right, else, which is right to left, then it's going to be a length of level that we said here, minus I minus 1. So exactly what we said here. And even here, it was length 0 was just length of level minus the position, the last position is length of level minus 1. Yeah, so basically it was this. That was the last position. Yeah, so let's see here. So now we have else, we have length of level minus I minus 1, and now we need to put in the level with this index, we need to put the value which is node.val. That's what we said here, right? And here. And now once we do that, we will need to add the left and right to the queue. So if node.left, actually we don't need to check if node.left is not null, because we are already doing this in a queue, right? So if a value is none, it won't work. It won't go inside the while loop. And at the end, we need to add the level here to our result so that we can return it. And so we're going to say res append level and we are going to return result. And we need to change, for the next level, we need to change left to right to be right to left by doing this. Actually, let's call this, yeah, so that it becomes false so that we can go right to left. Basically with this indexing, this is what determines whether we are going inserting in left to right or right to left order. Yeah, let's submit this. Yeah, so it's Python, so we need to do not. Okay, so that's the empty case. Let me take this case. We didn't define length of level. It's actually with uppercase length of level. Okay, so here we encounter the case for node. So I'll just say if node, otherwise do nothing. And here also we don't want to add an empty list. So actually, let's just if node.left, do this, and if node.right, do this. Okay, so that seems to work. Let's again complicate this case a little bit more. One, null, two, something like that. So this becomes this tree essentially. Choose it. Okay, so this works. Now let's submit and see if this passes. Okay, so this does pass, and yeah, so this is basically template DFS, with the only difference is keeping track of whether we need to add left to right or right to left. And doing the processing here, basically this part here is different than just vanilla BFS, so that we can determine where to put the result. So this is where we are doing our processing. And here we are changing so that next time we do right to left instead. Yeah, and that's it for this solution. Now we can also do another solution that is not DFS or BFS, but it's a little bit similar to a stack. So it's actually kind of DFS, but a little bit modified. So we can have two stacks. And for the left to right level, we can just add to the stack, but for the right to left level, so left to right level, the level where we need to add left to right, then add to push to stack, let's call to stack S1 and S2, push to S2 with the order left first, then right. And then for right to left, push to another different stack, which is S1, with order right first and then left. And so what this will allow us is basically for the so when we push to a stack, the last one that we push it is going to be popped first. And so if we push left first, and then right after that, the first one that will be popped is right. So actually, what we want is the reverse here. Yep, the reverse here. No, actually this is correct. So basically for the left to right, we are going to push, for the left to right, we are going to push to S1. And then for the right to left, we are going to push to S2. Basically, the gist of this is that for right to left, we want right to be first. And so if we push left first and then right, that means when we pop, we'll pop the right first, and that's what we want since we want to write to level order. And so let's just change this to pushing to S2 here. It doesn't matter, we can use whatever order we want. And so let's try this out. And so basically for each iteration, do both. Do the left to right, do two levels, yeah. Which means push to S1 and S2. And so that would mean we are going to start out with 2. So first we need our res, and we need to check if not root, which means it's empty. We need to just return that res, and then we need to do our 2 stacks. Our first stack, since it's, so basically for the right to left level, we are pushing for, so for the right to left level, we are pushing to get the left first. And we are going to start out with the left to right level. So the first one will contain just the root, because let's call this S left to right. So basically S1 is for left to right, and then S2 is for right to left. And so we will push, and so what we are going to do is, while either of them is not empty, because we need to traverse maybe the last level, maybe left to right, or it may be right to left. And so we are going to have a temp to hold the level, hold the content for us, and then while S1, we are going to pop from S1 to get the node, and then we are going to add the value of the node. And now since we are at left to right, that means that the next one is to fill for right to left, right? That's the next level. Which means to fill for right to left, that means that we need right to be popped first, which means right need to be pushed last, right? That's how stack works. So that means we need, in our second, we need to push node dot left first, so that we can push node dot right last. And we do a similar thing for, and then we need to add that to the result, right? And then we need to do a similar thing for S2. And of course we shouldn't add an empty value, because that may happen if this may happen if there was no level after the element has no values. Well, that may not happen, but yeah, that may not happen. Can't happen, right? Well, it may happen if S1 was empty and S2 is the one that has values, right? In that case, we will not enter this while loop, and this one will be empty. We don't want to add that, and so we need to check this. For S2, we need to pop from S2 instead, add the value to node.val, and we need to, so this one is the right to level, right to left, sorry, right to left. And that means that next one to fill for is left to right, which means needs left to be popped first. It's left to right, which means needs left to be pushed last for it to be popped first, right? And so that means we need to push right first to the other, because left to right is here, we need to push to S1. So we need to append node dot right. And then we need to do the same thing for left, and it needs to be done last, which is what we are doing here. And now that we did this, the only thing left is to check if temp is not empty, because it may be if S2 was empty. then we need to append to res, and at the end we need to return res, right? So that's pretty much it. Let's run this and make sure we don't have, yeah, so it's Python, so let's need to have append. Cool. Yeah, so stack here, let's just append. Okay, so we have some duplicates here. So we are popping the node, we are adding the node value, we are checking that we had left, we are adding that, we are checking if we have right, we are adding that. We are adding to res. Yep, so one thing we didn't do is here we are adding on top of what we added for this level, so we have the level add that contains both. But what we need to do is to separate the left to right level from the right to left level, so that we don't so yeah, maybe I can just say, even to make it easier to read, so this one is left to right, if left to right, left to right, and this one right to left, right to left, right to left, and right to left, so that we don't have. Okay, so that should be it. Let's submit. Yeah, so this one uses 2 stacks, and yeah, the insight from this one is we are not limited by essentially using just 1 stacks or 1 queues like we do for DFS and BFS. We can use 2 stacks, 2 queues, whatever helps us. And in this case, we are taking advantage of the fact that if we append right first and left last, then that means when we pop, we'll get left first. And if we do the reverse, which is push left first and then right after that, when we pop, we'll get right first. And so we'll get the right to left order just by using the property of the stack that if you put a value last, we are going to pop it first. And that's essentially what we are doing here. And yeah, so that was the last solution for this example. And yeah, see you next time. Bye.